All right, so in this video, we're going to be using the Pythagorean theorem. So remember in the last video we introduced the Pythagorean theorem and then we proved it. Now in this video, we're actually going to be using it to find these missing sides of these triangles. All right, so real quick, let's recall the Pythagorean theorem. It says, if a triangle is a right triangle, then a squared plus b squared equals c squared. All right, that's pretty much it. If a triangle is a right triangle, that's probably the most important part. If a triangle is a right triangle, all right, so pretty much if it has one of these boxes, okay, if it has a right angle, if a triangle is a right triangle, then a squared plus b squared equals c squared, where a and b are the legs. All right, that's important. Okay, a and b are the legs. We're always going to refer to these sides here next to the right angle as a and b. Okay, just so we're consistent. We could change letters, right? Letters are just letters. We can change them around, but you do want to be consistent with the fact that you keep these two as the legs, and then what they're equal to as the hypotenuse. Okay, it's very important that you're consistent with that. All right, so a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. All right, so let's just go ahead and start this first example. This one says find c. Okay, so let's go ahead and try to do that. It says find c, and we're given this triangle. We're also given this nice right angle, okay, this nice box in this triangle. Now, because we have a right triangle, then that means a squared plus b squared equals c squared. So a and b are the legs. So in this case, we're going to have 3 and 4 are the a and the b. Okay, it doesn't matter the order, but let's just be consistent. So maybe we'll say, in this case, maybe we'll say the a is equal to 3. And then we'll say the b here is equal to 4. Okay, it doesn't matter. You could swap them around. You'll still get the same thing. All right. So now we're going to say a squared plus b squared equals c squared. So now we're just going to plug in 3 for a, and we're going to plug in 4 for b. And when you do that, you're going to get 3 squared plus 4 squared equals c squared. Okay? What's 3 squared? 3 squared is 3 times 3, right? Thing squared is thing times thing. So 3 squared is 3 times 3, which is 9, plus 4 squared is 4 times 4, which is 16. Okay, and that's equal to c squared. But we can go one step further. Okay, 9 plus 16 is 25, which is going to be equal to c squared. Okay, and maybe this looks a little confusing on the order it's written in, but thanks to equality, we can just flip it around. I think it makes more sense to, it looks a little bit more ordinary if we just change the order. So instead of 25 equals c squared, let's do c squared equals 25. Okay, so did we find c? Right, the direction said find c. Okay, that means we need to get c by itself, all right, when we set up this equation. But c right now is not by itself. C right now has a squared next to it. And how do you get rid of a squared? Remember from a few videos back, you have to square root both sides, right? Square root both sides. And if you remember even a little bit more, when you square root both sides, you also have to add the plus or minus, right? So now what's going to happen? Now the square root sign goes away and the squared sign goes away, and you're left with c is equal to plus or minus the square root of 25. But what's the square root of 25? That can be simplified, so we don't want to leave it like that, right? So we'll say c is equal to plus or minus square root of 25 is 5. All right, you guys should be very familiar with that one. Okay, so we get c equals plus or minus 5. All right, but now what's nice about geometry as opposed to algebra is notice we're talking about find C. That means we're finding the length of this side. Length can't be negative. So that means we can just throw away the negative solution that we get. All right, so what we can just say here is we could circle it kind of like this. Okay? Or if you wanted to, you could just write C equals 5. All right, and that's pretty much how you go about that problem. Let's go ahead and look at this problem. Okay, this one, same thing. Okay, they want you to find C, find the hypotenuse. You're given both of the legs, so you use that. So you assign A a value and you assign B a value. It doesn't matter which, as long as you're consistent. Okay, so let's say A in this case is 5, and B in this case is 13. Okay, so we're going to use the formula. We're going to use A squared plus B squared equals C squared. Why? Because we want to find C, and we're given that this is a right triangle because of the box. Okay, this right angle here means it's a right triangle, so we use Pythagorean Theorem to find the missing side. So what we're going to do here is A squared plus B squared equals C squared. Okay, what's A squared? Well, A squared, A is 5, so A squared is 5 squared. So we're going to have 5 squared plus B is 13. So B squared is going to be 13 squared equals C squared. Okay. But now what's 5 squared? Well, 5 squared is 5 times 5. 5 times 5 is 25 plus 13 squared is 169. Okay. Equals to C squared. Okay, now you want to do 25 plus 169. So what I would do is I would adding numbers like this can be difficult sometimes. So what I would do is I would take one of these ones away from 25, and I would make this 169 170. And instead of doing 25 plus 169, I would do 24 plus 170. 24 plus 170 is 194. Okay, it's a little bit easier that way, in my opinion. Okay, or if you just saw it, you could do it that way also. But we get 194, and that's equal to C squared. Okay, now what we can do here is we can do this. So now we can do what we did in the previous problem. We can rearrange it so that it looks a little bit nicer. So C squared equals 194. Okay, and now we want to get rid of the squared, so we square root both sides. What you do to one side, you do to the other side. All right, so now what we get is this squared goes away and the square root goes away, and you get C equals the square root of 194. Okay, and we're not going to try to simplify that. We're just going to leave it alone because square root of 194, it doesn't have a perfect square. So what we're just going to leave it alone. Okay, we'll keep it in exact form. All right, and that's it. We get C is equal to the square root of 194. I should have added the plus or minus here. Okay, but now you guys should see that you don't. In this case, the minus doesn't apply because we're talking about lengths. All right, so we just get C equals the positive square root of 194. All right, so now in this next video, in this next problem, it says find B. Okay, find B. So now we're given the hypotenuse. Okay, so let's look back to the equation real quick. A squared plus B squared equals C squared. Now we're given C. Okay, so you want to be careful. All right, so let's say that A is equal to 8. So instead of A squared, we're going to do 8 squared. It says find B. So that means we don't know what B is. So that means we're going to keep B squared as B squared equals to C here. C is 10. So C squared is 10 squared. So we plug in 10 squared. And then now we're just going to simplify. All right, so 8 squared is 8 times 8. 8 times 8 is 64. Plus b squared, we don't know, so we keep it just like that, equals 10 squared. 10 squared is 10 times 10, which is 100, right? Then we want to get the b by itself, right? We want to find b. But if we want to get b by itself, we should probably get b squared by itself first. All right, so what we'll do here is we'll subtract 64 from both sides. What you do to one side, you do to the other side. And when you do that, 64 minus 64 is 0, goes away. And you get b squared equals 100 minus 64 is 36, right? And then we'll take the square root of both sides to get the b by itself, right? Because we have b squared equals 36, but we want to get the b by itself. Remember, to get rid of the squared, you square root both sides. All right, so now the squared goes away and the square root goes away, and you get b is equal to plus or minus, but we don't need to worry about that because we're talking about length, so we'll just worry about the positive part. The square root of 36, but you guys know that the square root of 36 is 6. So you can just say b equals 6. All right? And finally, this last one, it says find a. Okay, so let's go ahead and try to find a. So we're going to do, I like to write down the Pythagorean theorem before I start the problem. It makes it a little bit more organized, just in my opinion. So a squared plus b squared equals c squared. We don't know a, right? That's why it says find a. So for a squared, we're going to have to leave it as a squared. Plus b, we do know. b is this leg here. All right, which we do know is 4. Okay, so instead of b squared, we can plug in 4 squared. Okay, and then after that, we know c is 7. So for c squared, we're going to do 7 squared. Now we can do some more simplification, and we'll get a squared plus 4 squared is 4 times 4, which is 16, equals to 7 squared, which is 7 times 7, which is 49, right? And then finally what we can do here is we want to get a. We want to find a. So we should probably get a squared by itself first, right? So you don't just want to square root both sides right now. Okay, that's against the rules of algebra. You can't you don't want to square root over addition. Okay, so first you need to get rid of the 16. Subtract 16 from both sides, and then you'll get a squared equals 49 minus 16. Well, break it up if you want, okay? So maybe you don't have to use a calculator here. Think about it. 16 is 10 and 6. So instead of taking away 16, take away 10, and then take away 6. So 49 minus 10 is 39, and then 39 minus 6 is 33. Right? So now we have a squared equals 33. Now we can do the square root, take the square root. And when we do that, the squared goes away and the square root sign goes away. And we're left with a equals the positive square root of 33. All right, and this we're just gonna leave this alone. Okay, it can't be simplified. And that's it. A is equal to the square root of 33. All right. So hopefully this made sense. We're going to do a bunch more practice with this and also look at some nice word problems that I'm going to go over in the next couple videos. All right, guys, thanks for watching.